Hello, everyone, and welcome to today's webinar, where we'll be addressing the topic of cybersecurity risk assessment and looking at whether or not likelihood should really come in and be a part of that equation. And so really what we've seen is that, we continue to have major cybersecurity incidents. The level of interest and really visibility in these within organizations, both operating asset owners as well as regulatory and legislative agencies, has never been higher. And so one of the big questions is, well, how much risk do we have? What is the risk of a potential cyber attack? And also, what do we need to do to mitigate that? And so one of the key steps in answering those questions is to conduct and complete cybersecurity risk assessment. And so with this being a really critical activity, we've seen a number of different methodologies be defined and outlined in terms of how to complete this activity. And so one of the main standards that we'll look at is the IEC or ISA 62443 3-2 standard that really specifically outlines a multi-stage approach for conducting risk assessment. And the other reference that we'll look at is consequence-driven cyber-informed engineering, which was identified and defined by the Idaho National Laboratory as another approach for evaluating cybersecurity concerns and really specifically looking at critical infrastructure or those most critical devices. And so we have, a lot of these different methods, and one of the biggest sticking points in the industrial cybersecurity community, something that experts, have kind of been a little bit at odds over, is whether or not likelihood has a role or has a place in cybersecurity risk assessment. And so what we're going to do in this webinar is really evaluate what are the methods that are out there, look at what are some differences and similarities between these methods, and then evaluate, does likelihood really have a place? And if we are going to use it, what are some practical ways to make sure that we are being as accurate as possible? This webinar does have a chat and question tool. So as I go throughout the presentation, please don't hesitate to ask any questions. We should have about 10 minutes at the end of the presentation to go through those. Before jumping in any further, I'd just like to give a brief background on myself as well as on Exida. My name is Patrick O'Brien, and I'm a safety and cybersecurity engineer. I've been working at Exida for a little bit over 6 years now, and have a background on chemical safety. So I really started out primarily in functional safety and safety-based risk assessments or HAZOPs for chemical plants and other industrial applications. And over time, we saw that cybersecurity really was becoming a driving risk and really had a critical impact on the overall risk of those facilities. And so for the last 4 years now, I've also been heavily involved in cybersecurity risk assessments and have worked with many different customers in many different industries on going out and completing those risk assessments. At Exida, we really are a customer-focused company, and we work with customers in 3 different areas to really help them achieve their goals. The first is our certification and assessment division, where we are able to provide independent third-party certification to a number of functional safety standards, such as IEC 61508 and IEC 61511. We're also able to provide cybersecurity certification to the ISA Secure Scheme as well as exida schemes developed based on the IEC 62443 standards. And those are available for products, systems, personnel, and processes. We also have a lifecycle services division where we work directly with the asset owner to help them tackle their functional safety, cybersecurity, and alarm management needs. And so going out and completing a cybersecurity risk assessment would be something that we do out of this group. And then lastly, in our enterprise tools, We've actually developed internally within exida a number of tools for supporting functional safety, such as the Excelentia tool, cybersecurity risk assessment with our Excelentia cyber tool, and alarm management using the SIL alarm tool. And so originally the Excelentia platform was first designed for internal use, but we saw that a lot of our customers that we were working with would benefit from having it as well. And so now these software options are available to be purchased outside of exida. And so in this presentation, as we tackle and really look at our risk assessment methods, we're going to cover it in three areas. So the first area is, why are organizations going out and completing risk assessments? What are the drivers for risk management? And how does that shape, what we need to be able to find during our risk assessments? Next, we'll look at what risk assessment methods are available and really dive in and take a high-level look at what steps we would complete or what the process is for each of those different methods. And then finally, we'll evaluate what are the benefits and drawbacks for each of the different approaches. What are some ways in which a consequence-only approach would be beneficial? Or what are some of the benefits or drawbacks of also looking at likelihood to really try to understand, for a given system, for a given need, what would be the best method to select? And so when we look at why do organizations complete risk assessments, it's helpful to take a step back and really make sure that we understand what risk is. And so risk from a general sense is a measure of both the likelihood and consequence that we would see an adverse effect. And so, thinking about how often can a negative event happen, and when it does happen, what would be the extent or the severity of that impact? And so specifically in the IAC standards, risk is defined as the probability that a particular threat will exploit a particular vulnerability with a particular consequence. And so at a high level, when we're defining risk, we do need to be thinking about both the likelihood and consequence, and that really helps us to have consistent criteria for ranking and comparing risks. And so when it comes to companies and taking steps to manage the risk, they have a legal, moral, and financial obligation really to limit the risk posed by their organization. And this is true whether we are talking specifically about cybersecurity risk, whether we're talking about the risk of a safety impact or loss of containment event. For whatever the company is doing, they really need to meet and look at all of these three areas. And if we can understand how this is expressed within an organization, we can hopefully have a better understanding of what risk assessment method would be beneficial. And so if we think about it, we need to take all of these areas and really consider them together, because if we take any one in isolation, we won't be making optimal risk management decisions. And so even from the moral side, if we think about, well, what could be wrong with trying to make a plant as safe and secure as possible? If we take actions and totally disregard cost, we're not going to be able to really provide operations. So we won't be able to provide products to our customers, and we wouldn't be able to provide jobs to the employees. So even though it might seem like the correct moral thing to do, it's really not leading us to a desired state. And so we need to look at balancing our moral obligation to make the plant safe and secure with the financial obligation to be able to have safe and secure operations while still making a profit, while still employing, and also look at how we can comply with regulatory requirements in a way that not only will help us to avoid fines, but also ensure that we are doing things in a practical way and really looking at the overall risk. And so we really need to understand that there is not going to be zero risk in the real world. For any industrial site where we have operations, there are potential risks such as loss of containment or loss of operations. And so we need to really look at how we manage that. This is also true from the cybersecurity perspective in that there is no system that is completely unhackable. Given enough time, attackers will be able to compromise and make unauthorized changes. And so we need to think about how we manage that risk if we can eliminate it. And so the reason that these risks are tolerated is because they do provide a benefit or some sort of positive outcome from productions. And so, if we think about industrial sites, this could be, the profit or the critical products that are being made. This could be, supplying power or water to consumers. And so because we have these benefits, we have to think about, how we can manage and get the risk to a tolerable level. And so to do this, we really need to be able to measure both risk and benefit to have a good comparison and to really understand, what are the consequences and likelihoods and how does that, compare to the benefit that we're getting from that scenario. And so part of that, and really a critical part of risk assessment, is understanding how we can model risk for security. And so if we remember from our earlier slides, risk is really a measure of consequence and likelihood. And so for cybersecurity specific concerns, the likelihood is going to be the likelihood of a successful attack that could cause a catastrophic event or a negative consequence. And there have been a lot of studies or approaches taken to try to see how can we break down this likelihood. And what we commonly see is that the three variables that will really go into the likelihood of a successful attack will be the threat. So thinking about the type of person or the threat agent who is able to go out and cause that type of attack, the vulnerabilities or the weaknesses that can be exploited in the system, and the target attractiveness, or an estimate of how valuable that target would be to an adversary. And what we've seen is that the number of threat sources specifically to industrial automation and control systems is continuing to rise. We're seeing that there are a high prevalence of nation state type attacks or really advanced persistent threats, things such as the SolarWinds or really supply chain based attacks. We're also seeing that skilled attackers or cyber criminals are being heavily involved. As well as unskilled attackers or those who may not have the ability to develop hacking tools themselves, but can take and use tools that have been developed by other personnel or other cybersecurity criminals. And if we think about the Colonial Pipeline example, where we saw the ransomware really be the driver for that shutdown, that was a case where a ransomware as a service was employed, or essentially a skilled group of hackers developed a ransomware tool that they then shared with less experienced hackers who just had to work on trying to get that initial access. And so with that, with the increasing prevalence of malware kits and really hacking tools, we're seeing that more and more unskilled attackers actually have the potential to disrupt and have an impact on industrial automation systems. And then lastly, we can also think about disgruntled employees or any sort of insider access, whether it is an intentional disgruntled employee or some sort of accidental change. There are really lots of different areas that generate cybersecurity threats. We're also seeing a growing exposure to control systems with sharp increases in remote access. That 90% of OT organizations had experienced a damaging attack in the last 2 years. And so this is another one of those drivers for cyber risk assessment that we are really seeing this happen and affect many, many different organizations. And then specifically on the OT side, it's important to understand that cybersecurity risk isn't just a financial impact, that it can have safety concerns such as the targeted attack on a Saudi Arabian petrochemical facility. It can lead to environmental impacts. And we've seen attacks that have led to loss of containment of raw sewage and really disrupting the water sector. We've seen financial impacts through lost production, such as the Stuxnet attack, or equipment damage, which was also part of Stuxnet or attack. And we've also seen, many other impacts that can lead to lost production or loss of confidential data, and really negative impacts to less tangible qualities like company image or reputation. And so with all of these different drivers, we think about how can we go about assessing our cybersecurity risk and what techniques are able to do this. And so something that I always like to look at when determining the focus of a study is kind of set up a 2x2 matrix where we can look at a couple different criteria. And so the criteria that we will segment our risk assessment techniques based on is, are they quantitative or qualitative? So do we have any sort of numerical value that we're using? And then are they consequence only focused, or things that would look at consequence and likelihood? And so on the qualitative side, for consequence only, we mentioned that we've got the CCE methodology developed by Idaho National Laboratories, as well as initial risk assessment, which is part of the 3-2 standard. And we could also look at using different types of checklists, where really we want to focus on what are the most critical assets and what specific protections do we need for those assets. On the quantitative side for consequence only, we could look at quantitative risk analysis or QRA, and this is an area where the existing process safety or functional safety techniques can really be taken and applied to cyber, in that they give us a better understanding of what the worst case consequence would be of a cybersecurity compromise. And so we can really look at what would the impact area be, what would be the expected number of people in that area, to really drill down and get a little bit higher granularity. On the consequence and likelihood side, a qualitative approach, we could look at cyber PHA or detailed risk assessment, which is the second part of the risk assessment defined in IEC 62443-3-2. And here we're looking at how can we reduce the likelihood for the compromise of those critical assets to an acceptable level, and kind of bring that other element of the risk equation. On the quantitative side, there are some places where a QRA can be done on the likelihood, but a lot of times this will boil down more to equipment failure. And so we don't necessarily have a quantitative way to really drill down on the likelihood of a cyber attack yet. But we do have some approaches that have been identified for semi-quantitative SL verification, where we take a little bit more of a LOPA approach. And so if we first look at our consequence-based methods, we'll drill down and look at each of them in a little bit more detail. And so for our consequence-driven cyber-informed engineering, there are a couple of key assumptions in place. The first is that any and every industrial automation system is vulnerable to cyber compromise. And this is something that we're calling it an assumption here, but that's something that we really have seen to be true over and over again. There's no impenetrable system. We see myths perpetuated like the air gap, that is totally successful. But really in this digital age, those systems still have to be managed, and so there are many different ways in which that air gap can be breached. The next assumption is that critical industrial automation systems are increasingly targeted by aggressive and sophisticated threat agents. And again, this is something that we are seeing time and time again for those critical assets. We're seeing these major cybersecurity incidents. And so what we also want to look at is that with enough time, sophisticated attackers can and will be able to compromise any system. And really, regardless of what protections are in place, we really aren't able to eliminate that possibility of compromise. And so if we look at the process that's followed for the consequence-driven cyber-informed engineering, it goes through 4 phases. And so we'll talk about the phases in a little bit more detail on the next slide, but it's good to understand that we're really working on flowing through that cycle. We start with consequence prioritization. So what is our most critical assets? What are our highest consequence event scores? And then we look at really analyzing and building that into more detail with our subsequent steps. we do also want to think about this as really trying to get inside the mind of an attacker, where there's an evaluation of the kill chain, thinking about what are the specific pathways, what are the goals of that attacker, and using that in order to try to understand and think about what are the protections that we could use. And so in our first phase, when we look at the consequence prioritization, we're really trying to ask the question, what are the systems that must not fail? If we look at a utility or critical infrastructure, you know, let's go with a water example, but the supply and chemical dosing of drinking water must not fail. We can't have scenarios in which we could have some sort of poisoning of the water supply. And so there are certain things that we would look at and say this is critical to X number of members of the public, and we need to make sure that that doesn't fail. And so that might be something that has a high consequence priority. Next, we want to do a system of systems analysis, or really think about what information do we have about our SCADA system for the water supply? What do we know about how we're managing the chemical dosing? And so really pulling all of that information together, gathering our system vulnerabilities and understanding all of that data that attackers would need, or really the different pathways. And that is what is going to feed into phase 3, or the consequence-based targeting, where now that we have that detailed information, we have that input, we start looking at and evaluating what are the different access pathways that could be used. Are there network-based compromises? Do we have unsecured remote access? Do we have exposed endpoints? We could look at it from the personnel side, or are we susceptible to social engineering? Clicking on phishing links, not having strong passwords, sharing information. So, thinking about anything from the personnel side, and then lastly, supply chain. Are there ways in which our suppliers could be compromised that would compromise our system as well? And so in addition to looking at the pathways, we also want to think about, well, where are the attackers trying to go? What targets on the network would need to be compromised in order for them to execute that attack? And that helps us to really understand what are the different places in which we could stop the attackers or prevent them from getting there. And then the final step is mitigations and protections. And this is really looking at it from a backstop or fail-safe perspective. So we're not going to kind of come through the CCE process and come out with a recommendation to, let's say, improve our antivirus, or have more monitoring on the system. What this is really looking at is, even if all of those measures are in place, there's still the possibility that attackers can come through and compromise the system. And so for these most critical systems, we're really looking at what manual backups or things can we do to really try to take this out of the attacker's hands, or have some sort of manual means of disconnecting and going through manual operations to provide that critical service. And so it's not meant to be, let's say, a step back from the cybersecurity countermeasures that are being looked at, but it's really more of a way of saying, yes, those are good, important things to do, but for systems that must not fail, they're not enough. And so we need to look at these backstop or fail-safe options. And so that gives hopefully a pretty quick overview of what the CCE-based approach would be, where we're really focusing on consequence and thinking about protecting those critical systems. On the IEC side, we also have a step where we really look at scoping and identifying critical assets, and using that to set up the zone and conduits, or really look at our network segmentation strategy. And so this comes from the 3-2 standard and is really that initial risk assessment. And so for this approach, we want to pull in all of our existing safety risk assessment information, our device inventory, and our risk criteria, and then really step through and look at, for each device, what is the worst case scenario, identify what our security level target would be, or how high the risk is if we assume a likelihood of 1. And then from there, we start the mitigation process by grouping devices with similar targets into zones, and then looking at, how would we respond if that zone was compromised. And so because we're assuming a likelihood of 1, that's where this is really a consequence-based method where we're only evaluating the risk or the security level target based on how severe the consequence is. And so, for our example here, as we get to higher risk, we're going to want to protect our system from a higher or more sophisticated type of attacker. And so that'll increase from security level 1 to security level 4. If we think about something like a patch management server, if that's compromised, we may only have a minor business consequence. Whereas if we lose operator workstations or don't have the correct visibility to the process, that may lead us to make a decision to shut down or have operational or operability concerns. If we think about compromising some sort of controller that's used on the basic process control side, maybe that can trigger a significant safety consequence or have some sort of business impact, equipment damage scenario. And then for our highest security level target, that may be our safety critical system, where if that's not in place, we could have an event that leads to multiple fatalities. And so, when that happens, we want to look at and think about, well, what do we need from a network segmentation standpoint? How can we separate our most critical assets from our less critical assets to really set up and have an effective network segmentation in place? And so for our results of the initial risk assessment, we'll input whatever likelihood level corresponds to high or an assumed likelihood every year. We'll look at our consequence severity and then really use that to drive our risk decision. For the next piece then, if we think about adding in likelihood to the equation, there are both qualitative and semi-quantitative approaches that we can use. And so the first one we'll look at is cybersecurity PHA, or detailed risk assessment. And so this again is coming from our 3-2 standard. And so it's one helpful place to go and look at, well, what is the standard saying about likelihood? Is this something that we're even allowed to look at, or is it something that we have to look at? Trying to understand what is the standard saying on likelihood. And this was, as I kind of mentioned, very much a contentious point. And as the 3-2 standard was being finalized, there was a lot of debate over what wording should be used for likelihood. And so the 2 points that I want to kind of highlight in the detailed risk assessment step where we look at likelihood, excuse me, are that when we look at likelihood, it could either be qualitative or quantitative in nature. So both a qualitative or quantitative approach is allowed, and also that consequence-only risk assessment methodologies may be used to meet the requirements of the standard. So even though if we follow the normal work process, we do have steps in which we have to identify likelihood and can do that either qualitative or quantitatively, the standard does also allow for a consequence-only approach. And really, the thing to realize is that even if we talk about a risk assessment approach being consequence only, they're still making an assumption on likelihood. And instead of trying to say find the value, they just assume it to be 1 because either A, it's not really the important part of the study to focus on, or B, if we don't have enough information to make an accurate assumption on the likelihood, we should take a conservative approach and just assume that to be 1. And so that's where, when we even do detailed risk assessment, the standard does give us some leeway to either consider likelihood or to focus just on consequence. So this is where we move from our zone and conduits and then really look at analyzing the security risk for each of those critical zones. And so from an input perspective, we pull in the results of the high-level risk assessment as well as all of those process safety inputs. Here, we want to document what are the specific threats that we're looking at and evaluate the threat likelihood. Then from a consequence determination standpoint, this is where we can really pull over the consequences that we've already defined in our high-level risk assessment. We can also look at taking credit for countermeasures and thinking about how those would reduce the likelihood of an attack being successful. And so when it comes to documenting threats and threat likelihood, we want to think about what type of threat agents or what type of attackers could compromise or gain access to the network in that way. So we want to think about, is it something that requires internal or external capabilities? Are they skilled or unskilled? Do they need to be a nation state or have those level of resources? And each of those questions can help us get a little bit of a better understanding of what that likelihood may be. And so when we think about threat likelihood, we do want to understand it and always say the caveat is that it is difficult to accurately estimate and determine attack likelihood. A, due to the sensitive nature of cybersecurity incidents. B, we don't really have those instant repositories where we've got a centralized database tracking all of the types of attacks to really see how likely are these different scenarios. And so when we do use likelihood, the goal should be to use a conservative estimate that still gives us some sort of reasonable approximation for real world events. And so what we've seen is that the higher the sophistication of the attack, the less likely that it may be. And so what we would say is kind of our starting order of magnitude estimates that can definitely be refined and adjusted based on the target attractiveness and the region of a facility, is that before adding in target attractiveness, we might say that a nation state attack, a truly targeted, sophisticated attack where they are trying to compromise critical assets and trigger some sort of safety scenario, might occur more on the order of magnitude of once in 100 years. Whereas a targeted attack that is still skilled but doesn't necessarily have the nation state resources may be more common at once in 10 years. A general targeted attack could be once per year to more frequently, and then general malware or unintentional attacks may be much more frequent, 10 times per year or more, looking at almost some sort of continuous mode there. And so we know that these aren't the exact values, but the goal of this approach would be to make sure that we aren't always looking at just low likelihood, high consequence severity issues, that we do consider, are there potential, let's say, higher likelihoods to some sort of general type attack that could have a negative impact as well, to try to have comparisons or overall risk comparisons between different scenarios. And so when we are moving on from the threats, we also want to think about the threat vectors. And again, what are the different pathways into the system? And this is an area where there is definitely a lot of commonality between the CCE approach and the 3-2 approach. And these aren't even necessarily conflicting approaches or standards. They're just kind of two different ways of defining how to go about and look at that risk assessment process. And so we could look at things all the way from social engineering through supply chain and the personnel side to communications and physical software, hardware, kind of some of the different ways that we can categorize or look at the system vulnerabilities. The other thing that we want to look at in the cyber PHA is what are our countermeasures that we can look at for identifying that attack is in place and stopping it, reducing the consequence, or reducing the likelihood that the attacker gains entry to the system in the first place. And so although we may not be able to totally eliminate the possibility, if we can build independent layers, independent countermeasures, we can make it more difficult for the attackers to gain access and give us more opportunities to identify and mitigate that potential attack. And so then looking at the results of the detailed risk assessment, we can then build on from where we were at the high level risk assessment, include countermeasures as well, and then use that to try to estimate qualitatively what the likelihood is. As we move from a purely qualitative approach to a little bit of a more quantitative or semi-quantitative approach, what we want to be looking at are kind of our key ideas are likelihood modeling, or thinking about how can we analyze a chain of events to get a better understanding of what will lead to that incident. And so the idea or the goal here is to break a problem into smaller, more generic events where we'll be more likely to be able to have statistical data, and then use probability logic to combine that and get our overall likelihood. And so for semi-quantitative SL verification, we essentially are providing a method to try to translate the chain of attack or the different steps that are going to occur in a sophisticated cyber attack and look at, can we break that down into a little bit more of a semi-quantitative or a likelihood calculation? And so this would pull from a lot of the same inputs, pull from our cybersecurity risk assessment, our tolerable criteria, and then we would go through a process of transferring that information, evaluating how would things like the target attractiveness or the different cybersecurity kill chain steps impact the likelihood. Are there any physical conditions or conditional modifiers that we could look at? Which of the countermeasures that we identified are applicable? And really, how could we use those and what would we estimate for their effectiveness? From there, the goal to get some sort of comparison between the estimated likelihood of success and really what our target likelihood would be based on our risk criteria. And so this is an example Cyber SL worksheet from the Exida Cyber tool, and that was where our screenshots from the Cyber PHA side had come from. And this shows, kind of how we can take and apply that LOPA-based methodology. The key is that, still the best that we can do is really order of magnitude estimates. We don't have, the same level of data that we do for a pressure relief valve to point and say, we know this fails once in 100 years. We can't look at a firewall and really assess that in the same way currently. But it does still give us a method to try to compare, well, what's the likelihood of a successful attack to our target likelihood? The next question we could think about is, well, if we've got a semi-quantitative approach, is a fully quantitative approach viable right now? And so because of all of those reasons that we've talked about, not having that central database, not really being able to know and point to what the threat likelihood is, we would say that currently we would not recommend taking a fully quantitative approach. That semi-quantitative is really, say, that bleeding edge right now as far as we can go. But we don't necessarily think that that's going to be where the industry is forever. We're seeing a number of industry efforts underway to really try to build that central incident database. So CISA has an initiative for a central incident repository that will hopefully promote some information sharing and a little bit better tracking of incidents. We're also seeing that a lot of the new regulations that are coming out really across the world do also include reporting elements to try to capture that data and understand the risks for their different areas. And so similar to on the functional safety side, where at first, the best that we could do for PHA and LOPA was truly qualitative. And over time, we started to get better data to have a little bit more precision. I think that is something that we may see as well on the cybersecurity side. And that may really shift the debate or the questions on, does likelihood should it be considered? And now when we look at comparing the different risk assessment methods, the question is, well, which one is right for me, or what are the benefits of these different approaches? And where I want to start with this discussion is a quote that this is something that I think is so helpful to think through it and is really critical for whatever type of risk assessment you're doing, or even any type of model outside of this space, is that all models are wrong, but some are useful. So none of the risk assessment methods that we've looked at today are going to give us a perfect representation of the actual risk. None of them are going to perfectly capture everything. We don't have all of the information that we could ever need or want. So instead, we need to balance the time and resources involved with the risk assessment to see, what about the quality of the outputs? Are we getting something that's useful and that helps us to better manage our cybersecurity risk and really tackle all of those moral, financial, and legal responsibilities that we need to make? And so if we look at consequence-only risk assessments, the case or the argument for this approach would be that right now we don't know enough about the threat behavior to accurately model likelihood. Because of this, if we consider likelihood, A, it won't be accurate, and B, we're going to be spending time on the study and something that isn't effective anyway. We should focus just on consequence and make sure that we are protecting our most critical assets. Depending on if we're thinking about an initial risk assessment, that is going to give us our quicker big hitters, to look at network segmentation. On the CCE approach, we look at, what are the mission critical functions, and then what are the really fail safes that we need to put in place for those systems. If we think about the case for adding likelihood, if we point back to our risk definition from the beginning, if we're not looking at likelihood, it's not really a risk assessment. And so what we could argue is that even our consequence-only approaches are still making an assumption on likelihood. They're just making the assumption that the probability of compromise is 1. And so it is a conservative estimate, but is that a better estimate than trying to understand the likelihood of some different attackers? And so on the likelihood side, we might argue that even if we don't know the exact likelihood of an attack, we have seen that there are differences in the probability of attacks based on the level of skill. And so we know enough to say that there's more general malware out there, that we're more likely to, if we don't have any protections in place, see an issue with that than we are necessarily to have a specifically targeted attack against an individual facility. And so if we do add in likelihood, that might give us a better way to, tie in with our corporate risk criteria. So using the same matrix as our functional safety side, we can look at comparing what is the impact of, say, really high likelihood events that may have a medium consequence severity versus lower likelihood events that have high consequence. So we want to, think about both consequence and likelihood here to really understand the overall risk. And so if we look at breaking down and comparing the assessment methods, kind of highlighting some of the pros and benefits of each versus some of the cons or drawbacks. So consequence only, can be a quicker method. We take out one variable, we just focus on consequence and really look at protecting critical systems. We focus on those, those known consequences of critical assets, and really can make changes there. Try to install those fail safes or improve our network segmentation. And so this is going to be helpful in those measures, with the main drawback being that we may overestimate the risk of high severity, low likelihood scenarios and spend all our time protecting those assets when we may be missing other pathways that maybe aren't going to have the same uh, loss of containment event, but could be very financially damaging. And so that would be the only drawback is yes, we do absolutely need to focus on our high consequence critical systems, but we may not want to lose sight of the other consequences as well. From the likelihood side, now we're really measuring both aspects of risk. We've got the potential for better comparisons between our safety and cyber risk analysis. And that way we really have informed decision management where we have the full picture, and so we can understand what investment should we make on investing in cybersecurity countermeasures versus what should we design and implement into those fail-safe systems. The drawback is that assumptions on the likelihood will impact the overall results, and so if we are using assumptions that aren't conservative enough or aren't valid, then that is going to impact our result and would be something that would have to be periodically revalidated to make sure that those values are holding up and still look accurate. And so when we try to answer the question then of which approach, a lot of times it's helpful to think about what is our specific objective, or what are we trying to do? So if we are just focused on our initial asset prioritization, a consequence-based approach makes perfect sense here. Whether we're taking the initial risk assessment approach from 3-2 or looking at CCE phase 1, where we're really scoring and ranking those consequences, that is going to help us identify what are the most important assets and really look at where should we focus our attention moving forward. When we get to trying to have a more detailed assessment of our high consequence zones and think about, are we meeting our risk criteria, this is where I do personally see some benefits, depending on the application, of looking at both consequence and likelihood to make sure that we have that full risk picture, that we are really lining up with that cyber PHA methodology and making sure we're focusing our time and resources in the right area. then for our mission critical assets, so if we have something where the consequence severity is so high that we aren't able to mitigate the risk sufficiently low with our countermeasures, if any possibility of compromise is still too great, then we would really want to look at CCE phase 4 or that final part of the approach where we look at designing our fail safes. Do we need hardwired interlocks? Do we need manual backups or manual control options? And the reason that I say it's consequence and likelihood here is that we could absolutely jump straight from the asset prioritization to the mission critical approach, and just do it purely consequence based. And for some systems, if we're critical infrastructure or if we're supplying things to the public, that may make sense. We may need to take certain steps regardless of the cost. But for the majority of operating sites, there are absolutely mission critical systems that have safety and major financial impacts, but we want to balance the steps that we're taking to reduce that risk with the benefit. And that's where, if we can go through a consequence and likelihood based method, and see, are there things that are still coming out at too high of a risk, that really drives and gives the basis to then make the decision to have those fail safes. And so there are definitely ways in which both approaches can be used together. And the key is finding the method that meets the organizational goals, and helps them have the most effective overall risk management. For any of the methods that we choose, um, as long as we are taking steps to make sure that we have a useful model, measuring the current level of risk will help us to not only align our safety and cybersecurity activities, but it'll also let us take more informed risk management decisions to make sure that we are doing everything that we can to protect people and the environment from harm, as well as to protect financial investments into sites and ensure that continuous operations. And so we want to look at making sure that we're protecting our cyber critical systems, that we identify what those protections need to be, and then really use that to drive our organization forward and improve our cybersecurity posture. And so just to summarize, so we looked at what are the drivers for risk management, why do organizations go and complete risk assessments, what are the currently available cybersecurity risk assessment techniques, thinking about, are they qualitative or quantitative, and are they consequence only or consequence and likelihood. And then we also looked at what are the benefits and drawbacks for each of those approaches, and really trying to understand what could be the optimal blend to complete a risk assessment for a given site. And so I did see that a number of questions came in, and so if you want to jot down a couple of slides to go through before going to the question and answer. And so one of the things that we really have been doing since the pandemic, and really are continuing to see is very helpful, are the online live trainings, where essentially we can go through and do our training courses fully remotely, and really cover critical issues for functional safety, alarm management, and cybersecurity. The one course that I do want to highlight that's coming up in September is our CS 102 cybersecurity training course. This is going to be 4 half days. And if you thought the risk assessment topic was interesting and wanted to learn more, this is an area where we definitely dive in. We do some detailed workshop problems in the course, and would definitely recommend that as a next step in learning more about cybersecurity. And as I mentioned, that'll be something that I'll be leading next month. We do also have a number of online self-paced training courses. So if the dates of the training course don't work for you, or you want to be able to take something self-paced at your own time, the self-paced online options are definitely very a good approach to take there. If you thought that this topic was interesting and want to get updates for more webinars like this on the future, definitely follow us on the social media for all of the latest, as well as if you have any specific questions that we don't have a chance to go through now, don't hesitate to send me an email. My email is on the screen. It is pobrien@exida.com. Also, don't hesitate to add me on LinkedIn and ask your questions that way. I'm always happy to get questions on cybersecurity, and will do my best to respond quickly. And so now what I'll do is really jump in and start looking at some of the questions that have come in. Alrighty. So the first question is, how do we measure likelihood in IACS cybersecurity? Is it different from likelihood in conventional PHA? And so what I would say is from a cyber PHA or detailed risk assessment approach, where we are uh, let's say looking at a qualitative method, we would very much do it in the same way as a PHA, where we would look at our qualitative risk criteria and say, based on the level of skill, how likely do we think that will be? Is this something that we're going to expect it to happen yearly, every couple of years, or less frequently? And so use that as our likelihood estimation. And so this next question was, do we need to consider likelihood with TTP as per the MITRE ATT&CK ICS framework? And so I think that we can definitely look at different frameworks and see how those are playing and shaping the likelihood estimations. I think the MITRE ATT&CK framework is definitely a good reference for that. We use kind of the MITRE common attack way patterns and enumeration criteria or classifications to really set up what threat vectors we look at, and that also plays a role in kind of how likely is the attack to occur. Let's see. So this next question is, for safety related failures, past experience is a good guide to the future. Doesn't the world of cyber attacks change too much for this to ever be true for cybersecurity? Doesn't this mean that we can't have confidence in our estimations of likelihood? And it's a fair question. That's definitely something that the group that is firmly consequence only would point to and say cyber is changing so much so that we're never going to get to the point where we can estimate the likelihood. I think it's true that the pace of change is faster in cybersecurity, but that doesn't necessarily mean that we can't make estimates and we can't really see value in updating based on what we're seeing in the industry. And so, we may want to look at having a more frequent revalidation period. So, a normal risk assessment might be every 5 years. For cyber, maybe we need to review our assumptions yearly or every couple of years. And so that is something that we could look at. And we could also look at, really those trends and kind of see what's the rate of change and how can we bring that into the equation as well. All right, so we've got a question here about the 3-2 standard specifying that the risk assessment methodology adapted for initial as well as detailed risk assessment should be identical. I guess I don't know if I really understand what this question is asking, because within the 3-2 standard, the steps for both the high level or initial risk assessment and detailed risk assessment are defined, and they don't follow the same steps, right? Because in initial risk assessment, we're assuming a probability of compromise of 1 and just looking at consequence severity. Whereas in detailed risk assessment, we are looking at really all of those different steps. So I would say that there's really no conflict between the standard and the approach outlined here. But if you do have questions on that, I'd be able to try to I'd be happy to try to clarify that question a little bit more and make sure that my answer is in line with it. But from my understanding, I would say that looking at likelihood in detailed risk assessment is absolutely in line with 3-2. Let's see, another question I have here is, if we think about some different assets, a data historian, engineering workstation, and HMI, do they all have the same likelihood or different? What I would say here is that regardless of the asset, if we think about the threat type, we could have similar we're going to have, whether it's a nation state attack, we don't know specifically what they're targeting, so that may have some likelihood. And so I would say that the unmitigated likelihood for those attacks would be the same. As we look at what countermeasures and protections are in place, that would be where there may end up being differences in likelihood, because if we have more protection layers or more measures in place to protect our engineering workstation, that may then get compromised at a lower frequency. Okay, this next question is it rational from a cost point of view to use cybersecurity analysis over using general protections throughout? And so this one, I would say absolutely. And the reason is that for our critical systems, the general protection isn't going to give us adequate risk reduction, right? So if we've got something that can lead to an explosion at a refinery, if we are just doing the same protections that we would throughout our overall network, we're never going to reduce that risk low enough. From the same token, if we do everything that we need to do to protect our safety and BPCS controllers everywhere in the network, it's going to be financially not viable to implement those protections everywhere. And so in that case, doing that upfront investment in the risk assessment to really prioritize, identify exactly what's needed, really should, in the long run, reduce the overall amount of money spent on the protections, as well as reduce the financial loss due to cybersecurity impacts. So I would say that it is definitely rational from this point of view. This question here is, where are the vulnerabilities evaluated? And so this is something that would be done as a vulnerability analysis that typically feeds into the detailed risk assessment. And so what you would look at is, in addition to your consequence information coming over, you would also want to pull in the system-specific vulnerability information, because that'll inform both, what pathways are open, and then also how easy would it be for an attacker to compromise those pathways. So vulnerability absolutely plays a role in the equation, and it'll feed into that detailed risk assessment. Alrighty. Well, it looks like those are all of the questions that we have. Thank you very much, everyone, for your time. Again, my name is Patrick O'Brien, and if you do want to connect, don't hesitate to reach out on LinkedIn or send me an email. Have a great rest of your day.